explained. So today we would be solving exercise 11B calorimetry ICSE 10th. Hope you like the video. So starting with the first question, 10 gram of ice at 0 degrees Celsius absorbs 5460 joules of heat energy to melt and change to water at 50 degrees Celsius. So what is being given is we have 10 gram of ice which is at 0 degrees Celsius. It absorbs 5460 joules of heat energy to melt and change to water at 50 degrees Celsius. Now here what you have to understand is the ice that is melting, the same ice will be converted to water at 50 degrees Celsius. So by now you should have understood that the mass remains the same. That means the mass of ice and the mass of water will be the same. So we need to calculate the specific latent heat of fusion of ice. Specific heat capacity of water is given to be 4200 joules per kg per Kelvin. Now you have to notice one thing here, that is specific heat capacity is given in SI unit, that is joules per kg per Kelvin, and the mass is given in grams. So we have to convert either of them. So you can see two things are happening here. First, the ice is changing to water. So ice at 0 changes to water at 0 degrees. And after that, the same water which is being changed from ice is heated to 50 degrees. So it is very simple. We need to understand one thing. Wherever there is change of phase or change of state, we need to write M into L. And wherever there is change in temperature, we will write mc delta T. So for change of state, I wrote ml, so that is mass into latent heat, plus for change in temperature, I have written mc delta T. So Q is given to be 5460, that I substitute directly here, is equal to mass is 10 grams, so that can be written as 10 by 1000, into latent heat we need to find, that's what the question has asked, plus the mass remains the same, so 10 by 1000 I write it again, into specific heat capacity of water is given to be 4200 into 50. So 50 is the delta T, that is change in temperature for water, because the water after being converted to from ice gets heated till 50 degree Celsius. So delta T will be 50 minus 0, that is nothing but 50. So we can write 5460 is equal to 10 by 1000 is 0.01 into L, plus 42 into 5 gives us 210, into 10 gives us 2100, so we get 2100 here. 2100 is being taken to the other side and we get 5460 minus 2100, that is what I have written here. And this 0.01, it's been divided, so divided by 0.01. So 5460 minus 2100 gives us 3360 divided by 0.01. Now we multiply numerator and denominator by 100, we get 336000 divided by 1 joules per kg. Now you can definitely leave your answer here, but the textbook answer is given in joules per gram. Remember, joules per kg is the SI unit, but I have converted to joules per gram since the textbook answer is given in joules per gram. So 336 joules per gram. Coming to question number 2, exercise 11B, calorimetry. How much heat energy is released when 5 gram of water at 20 degrees Celsius changes into ice at 0 degrees Celsius. Specific heat capacity of water is 4.2 joules per gram per Kelvin. Latent heat is 336 joules per gram. So we need to understand one thing here. 5 gram of water was at 20 degrees, changes to ice at 0 degrees. So what is happening? The water is being cooled from 20 degrees to 0 degrees, and after that, when the water reaches 0 degrees, it gets converted to ice. So we have two things happening, that is change in temperature here and change of state here. So as I have already told you, whenever there is change in temperature, we will be using MC delta T, and whenever there is change of state, we will be using ML. So I just write Q is equal to MC delta T plus ML. Remember, the mass will remain the same because the same water gets converted to ice. So mass, I take it as common. What I get is C delta T plus L. I just substitute the values here. So 5 into 4.2 into 20, because the specific heat capacity is given in joules per gram and the mass is also there in grams. So I have not considered converting it. Plus 20 is the delta T, that is change in temperature, because the water at 20 degrees gets converted to 0 degrees. So 20 minus 0 will give us 20. Plus latent heat is 336 joules per gram. So coming here, 5 is taken down as it is. 4.2 into 2 gives us 8.4, into 10 gives us 84. So we get 84 plus 336. So we add 84 and 336, we get 420. So we get 5 into 420. So Q, we get it as 2100 joules. Getting into question number 3, calorimetry, exercise 11b. A molten metal of mass 150 gram is kept at its melting point 800 degrees Celsius. So we need to understand one thing, that if a metal melts at 800 degrees Celsius, it freezes also at 800 degrees Celsius. The temperature for melting and the temperature of freezing will be the same. It's just that melting is you are applying heat, you are heating it and it melts, and freezing it, it's losing heat, so it freezes. When it is allowed to freeze at the same temperature, it gives out 75,000 joules of heat energy. So when the metal is freezing at 800 degrees Celsius, it is giving out 75,000 joules of heat energy. We need to find what is the specific latent heat of the metal. So we have the mass here, that is 150 grams, and we know the amount of heat that comes out. Now you already know that whenever there is change of phase, we will be using ml. So simple thing, I would write Q is equal to m into L. So Q is taken as 75,000 because it is given in the question, is equal to m into L. So mass, I have taken it in grams only, that is 150 grams, into L, I have written it as it is. So we get L is equal to 75,000 divided by 150, because 150 goes to the other side, gets divided. So that is nothing but 7,500 divided by 15. So 15 fives are 75 and 2 zeros, so we get 500 joules per gram. I've got it in joules per gram only, it's not the SI unit, but the textbook answer is in joules per gram. That's the reason I've got it in joules per gram. Now there is a B part of the same question, that is If the specific heat capacity of the metal is 200 joules per kg per Kelvin, how much additional heat energy will the metal give out in cooling to minus 50 degrees Celsius? So they have told how much additional heat energy. That means we need not consider 75,000 and we need not consider change of phase. It has to be cooled to minus 50 degrees Celsius. So when it has to be cooled to minus 50 degrees Celsius, what happens is we get the change in temperature as 850. So delta T is equal to T2 minus T1. So we get it as 800 minus of minus 50. So that is nothing but 850, because 800 minus of minus 50, we get minus into minus as plus. So that is 850 Kelvin. Mass is given in grams, so I converted it here. That is 150 grams is nothing but 150 divided by 1000 kg. So that is 0.15 kg. I use Q is equal to mc delta T because there is only change in temperature. There is no change in phase. If there was a change of phase involved, I would have used m into L. So m is 0.15, that comes over here. C is 200 because it is given in the question. Specific heat capacity is 200 into delta T is 850. You can see the specific heat capacity is 200 joules per kg per Kelvin. So after multiplying all these, we get it as 25,500 joules. So the additional heat energy required is 25,500 joules. Now if the question would have asked you to find the total heat energy instead of additional heat energy, you just had to add 25,500 to 75,000. That would give us 1,500,000 joules. But since the question has not asked that, we need not do it. Getting to question number 4 of calorimetry, exercise 11b, ICSE 10th. A refrigerator converts 100 gram of water at 20 degrees Celsius to ice at minus 10 degrees Celsius in 73.5 minutes. Now we need to understand how many things are happening here. There is 100 gram of water which was at 20 degrees Celsius and gets converted to ice at minus 10 degrees Celsius. That means there are three things happening here. The first thing that is happening is the water is losing its temperature and is coming down to 0 degrees. Then what is happening is there is change of phase, that is the water at 0 degrees gets converted to ice at 0 degrees, and the ice which is there at 0 degrees then loses its temperature and goes down to minus 10 degree Celsius. The time taken for this entire process is given to be 73.5 minutes. So in 73.5 minutes the entire thing is happening. So we need to calculate the average rate of heat extraction. So whenever they tell rate of heat extraction, we need to understand that the question has asked us to find power. Definitely power comes in watt, so rate of heat extraction will come in watt if everything else is in SI unit. So you can see here specific heat capacity is given as 4.2 joules per gram per Kelvin. This is for water. Specific heat capacity for ice is given as 2.1 joules per gram per Kelvin. Latent heat is given as 336 joules per gram. So I have drawn a simple diagram which shows you what is happening here. Water at 20 degrees is getting cooled to water at 0 degrees. Then there is change of state, and then there is ice at 0 degrees, which is again getting further cooled down to minus 10 degrees. So for the first part, there is only change in temperature. So when there is only change in temperature, I use MC delta T. So MC delta T will be given here, plus change of state is going to be M into L. Wherever there is change of state, we just need to write mass into latent heat. And again we have change in temperature, so we can write MC delta T. So Q is equal to M is taken common from all these three because the mass remains the same 100 gram of water continues. So we get C delta T plus L plus C delta T. So first C delta T is for water and the last one is for ice. Now power is work done by time, which is nothing but heat by time. So heat can be written as power into time. So we have written Q is equal to P into T. In exercise 11A of calorimetry, I'll put down the link below. You can see there are similar sums wherein we have to substitute heat as power into time. So here also we are doing the same thing. So P into T is equal to, mass is given as 100, I've kept it in grams only. Then 4.2 into 20, so that is 4.2 is the specific heat capacity into 20 plus 336, that is the latent heat, plus specific heat capacity is 2.1 into 10 is the delta T for ice, because the ice is getting cooled down from 0 to minus 10, and this 20 is the delta T for water, because water is getting cooled down from 20 to 0. So now what I do is P into our time was given in 73.5 minutes. You can see here I've converted that to seconds, and we multiply by 60. So 73.5 into 60 is equal to 100 bracket of 84 plus 336 plus 21. So 73.5 into 60 gives us 4410 into P is written as P only is equal to 100 into 441. So P is equal to 100 into 441 divided by 4410. 0 cancels here, and 441 and 441 cancels. So what we get it as? We get it as 10 watts. So the power, or you can call it as rate of heat extraction, as I have underlined here, is 10 watt. Getting into question number 5 of calorimetry exercise 11B ICSE 10th. In an experiment, 17 gram of ice is used to bring down the temperature of 40 gram of water at 34 degrees Celsius to its freezing temperature. So there was 40 grams of water which has been cooled down from 34 degrees to 0 degrees, because freezing temperature for water is 0 degrees. And in order of doing that, the experiment we had to use 17 gram of ice. Specific heat capacity of water is given as 4.2 joule per gram per Kelvin. We need to find the latent heat of ice and we need to write down the assumptions involved. Now, assumption we will write it as no loss of energy. In all the calorimetry problems of both the exercises, we assume there is no loss of energy. And when the temperature of ice is not given, we usually take it as 0 degree Celsius. So, in any question, if they ask you what are the assumptions made, you can just write there's no loss of energy. In all the questions of calorimetry, that is what we assume. So, by principle of calorimetry, we can write heat energy gained by ice is equal to heat energy lost by water. So, ml is equal to mc delta T, because here what is happening is only the ice is melting. So whenever there is change of phase, we use ml, and here what is happening is the water is being cooled down to water at 0 degree Celsius. Remember, it is not cooled down to ice at 0, it is being cooled down to water at 0, and that is the reason we have just written mc delta T. So I just substitute mass of ice is given as 17 into L. I keep it as a L only because we need to find the value of L, is equal to mass of water is 40 into specific heat capacity is 4.2 into 34 is delta T, so that is change in temperature is 34. I just cancel 17 and 34, 17 2s are 34. So we get 40 into 4.2 into 2. So 4.2 into 2 gives us 8.4. So 8.4 into 40 gives us 336 joules per gram. Remember, this is not an SI unit. The question had asked us to find the latent heat and the answer given in the textbook was in joules per gram. In case you wanted to convert it to SI unit, you just multiply by 1000. So that would become 3,36,000 joules per kg. Delta T I have written here, that is 34 minus 0, that is 34 degrees Celsius or 34 Kelvin. This delta T. So coming into the question number 6, calorimetry exercise 11b. Find the result of mixing 10 gram of ice at minus 10 degrees Celsius with 10 gram of water at 10 degrees Celsius. So we just need to find out what is going to happen when we mix both of them. So for that, we will be finding out how much heat is being required for ice to increase its temperature from minus 10 to 0, and we will find out how much heat is lost by water to reduce its temperature from 10 to 0. Specific heat capacity of ice is given as 2.1 joules per gram per Kelvin. Latent heat is given as 336 joules per gram. Specific heat capacity of water is given as 4.2 joules per gram per Kelvin. So heat energy required by ice to increase its temperature from minus 10 to 0, since there is only change in temperature, we will be using mc delta T. So Q of ice is equal to mc delta T. So Q of ice is equal to 10 into 2.1, that is specific heat capacity for ice, into delta T, that is 10. So 10 into 10 gives us 100, 100 into 2.1 gives us 210 joules. So we need 210 joules of heat to increase the temperature of ice from minus 10 to 0. Now we need to find the heat energy imparted by water. That means the heat energy that is being lost by water in order to reduce the temperature from plus 10 to 0. So mass is given as 10 grams, it's the same. Specific heat capacity is 4.2 joules per gram per Kelvin. And delta T, that is change in temperature, will be 10 to 0, that is nothing but 10. So we get it as 420 joules. Now we need to see which has lost more heat or which has gained more heat. Now the amount of heat lost by water is 420 joules and amount of heat gained by ice is 210 joules. Now this is lesser than this. That is, the heat required by ice is lesser than heat imparted by water. So what we would do is the change of phase, we would equate it to the lesser value. Remember, we need to equate it to the lesser value. So we write m into L is equal to 210, that is Q of ice. So m we would get it from here into 336 is the L is equal to 210. So m is equal to 210 by 336. So that gives us 0.625 grams of ice melts. So the final result is 0.625 grams of ice melts when we mix this. Coming into question number 7, calorimetry exercise 11B, ICSE 10th. A piece of ice of mass 40 grams is added to 200 gram of water at 50 degrees Celsius. So there is water at 50 degrees Celsius in which we add certain amount of ice. The mass of ice is given as 40 grams. We need to calculate the final temperature when all the ice has melted. Now we need to understand one thing here. The ice which is melting, after that the same amount of ice is getting converted to water. So what is happening is there are two things happening in case of ice. That is, first it is melting, that is from 0 to 0, and then there is increase in temperature. Specific heat capacity of water is given as 4200 joules per kg per Kelvin and latent heat is given as 336,000 joules per kg. We just convert the ice mass of ice into kg, so 40 grams divided by 1000, that gives us 0.04 kg, and water, that is 200 grams divided by 1000, we get it as 0.2 kg. Now this equation which you see over here is the most important equation. That is, the ice is getting converted to water. So the ice which is melting, the same amount of ice gets converted to water, and then there is increasing temperature. So m of ice, that is mass of ice, into L plus the same mass of ice, so that is m of ice again, into C delta T, but now the ice has got converted to water. So specific heat capacity value will come for water and delta T will be the final temperature minus 0, because the change in temperature will be final temperature minus 0 is equal to mW Cw delta T. So that is mass of water into specific heat capacity of water into 50 minus Tf, because the difference in temperature is going to be hot body temperature minus final temperature. So mass of ice is 0.04 into 336,000 plus mass of ice that has got converted to water remains the same, that is 0.04 into specific heat capacity of water, that is 4200, into Tf minus 0 gives us Tf only, is equal to mass of water, that is 0.2, into C of water, that is specific heat capacity of water is 4200, into delta T is nothing but 50 minus TF, that is 50 minus TF over here. So 0.04 into 3,36,000 gives us 13,440, plus 0.04 into 4,200 gives us 168 TF, is equal to 0.2 into 4,200 gives us 840, bracket of 50 minus TF. So we get these left hand side things as it is down, that is 13,440 plus 168 TF is equal to 840 into 50 gives us 42,000, minus 840 into TF gives us 840 TF. So what we get over here is 840 TF. I take this 840 TF to the other side. It was minus 840, so when it goes to the left hand side becomes plus 840, plus 168 is taken down as it is equal to 42,000, and 13,440 was positive on the left hand side. When it goes to the right hand side it becomes negative. So we get 42,000 minus 13,440. So when we add 840 plus 168, we get it as 1008 TF is equal to, when we subtract 13,440 from 42,000, we get it as 28,560. So we get final temperature as 28,560 divided by 1008. So that gives us 28.33 degrees Celsius. So the final temperature when all the ice has melted is 28.33 degree Celsius. Hope you guys have liked this video. Since the video is becoming very long, I considered making it in two parts. Question number 8 to question number 12 is going to be there in the next video, the link for which you'll find in the description below. Do share the video with your friends. Dhanyavad.